Dodda.
Good morning, sir.
Morning everyone.
স্যার লাস্ট ক্লাসের পিডিএফটা তো আমাদেরকে দেওয়া হয়নি মনে হয়।
লাস্ট ক্লাস কি করেছিলাম?
এই থার্মোডাইনামিক্স এর অঙ্কগুলো করিয়েছিলেন, অ্যাপ্লাই কি করে করতে হয়।
ওকে ঠিক আছে, আজকে পাঠিয়েছি। Okay, so am I audible, everyone?
Yes, sir.
Yes, sir, you are
Okay.
audible.
Okay. Okay, so actually today we will discuss total heat transfer along with first law and second law of thermodynamics with question answer session. Okay, we will discuss all of these things, that whatever we have discussed up to this, we will discuss in one single class. Okay, after that we will take one more class, then we will move to the next chapter, that is called statistical mechanics. So before that I will take two class, one along with heat transfer and the first law and second law of thermodynamics, all the theoretical portion, some revision. I will check that okay. So if I start with heat transfer, so if I ask you one question, what is the main condition? What is the main condition of heat transfer?
Temperature difference.
Heat transfer.
একটা টেম্পারেচার বেশি হবে আর একটা বডির টেম্পারেচার কম হবে।
So one is that the temperature difference.
Yes, sir.
Is that clear for everyone?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So I will slow down the class because my syllabus is about to finish, because I have only one more chapter, that is statistical mechanics. That's why I am taking some revision class, and after some time later I will take some numerical problem again. Okay, so that type of class.
Okay, sir.
Sir, can you
Okay.
please give us the entire syllabus for the NSEM? Your
Okay,
subject
so
only
okay,
for
okay.
physics we haven't got one.
I have already transferred the uploaded the my part of syllabus.
Sir, but we have not got a PDF yet. For maths we got in the beginning of the semester itself.
Okay. I think that will be better if you ask the HOD. Okay.
Sir, okay, sir.
HOD means Krishnanu, sir.
Sir, Krishanu
Yes,
sir
yes.
is not giving. We've been asking for quite some time now.
Yes, sir.
Oh, what is
We have been asking for a long time. He's saying I'll upload, and he's not uploading. Same for the notes. He only uploaded 1 day of notes. If you could get
Okay.
us a PDF, it would be very helpful, sir.
Okay, actually, I have my part of this syllabus, not actually total part of the syllabus. That's why I'm asking, because he is the HOD. I think he has that syllabus. Okay, I will ask them because he is not in the university right now. He will come tomorrow. Okay, I will ask and then I'll inform to you. Okay. Is that clear?
Yes, sir.
Okay, sir. Okay, sir.
So actually, you can see from my part, you will see that whatever my actually the heat transfer, heat radiation, first law and second law of thermodynamics, then statistical mechanics. So brief introduction or elementary part of statistical mechanics. Whenever you will get the syllabus, you will see only the this portion is there. Okay. Okay, I will contact HOD after this class and ask about the syllabus. Okay.
Yes, sir.
Okay.
Thank
So
you.
first of all, that one main condition of heat transfer is only the temperature difference. You have to make sure that there must be some temperature difference. And what are the process of heat transfer?
Conduction,
What?
convection, radiation.
radiation.
Okay. So through this class, if anyone has any problem, please ask at that time. Okay. Radiation. So now if I ask you one question, what is the basic difference between the conduction and the convection? What is the basic difference? Conduction is also the transfer of process, process of heat transfer. Convection is also, and radiation is also. Now if I ask you what is the basic difference?
Means of
Or
heat transfer.
Direct contact.
Sudden
It's a mode of
conduction.
transfer.
Convection doesn't have the movement of particles, but convection has the actual movement of particles.
Exactly. So in the case of conduction, you can see that if I heat up a metallic rod, you will see, I already gave you some example. This is end A and B. You will see that after some time later, you will feel some hot temperature in the B region also. But this is some solid, right? And it's a metallic rod. So how the heat transfers from A to B? Here you can see, if I see the microscopical behavior of this metallic rod, you will see the molecules are attached tightly and they transfer the energy to the neighbor. But in the case of convection, convection means, let's say that air coming from low temperature region to the high temperature region because of the land bridge and sea bridge, you will see. That means air is coming from some region to the another region. So that means that air molecule taking that heat from that region. So that's why the direct transfer of heat without the actual movement of the particle, that is conduction, but with the movement of the particle is called convection. Now, Suman Viswas, is there any question? You are raising the hand. Okay. Now, what is the difference between radiation and convection? What is the difference in between? Medium. And if I ask you the question similar for this conduction also, that what is the difference between the radiation and conduction?
So no medium is required for radiation.
Which is same. Actually, if I ask you the difference between the conduction with radiation and also convection with radiation, which is same, that in radiation you don't have any medium, right? And you have
Yes, sir.
already known that electromagnetic radiation properties are actually similar with the electromagnetic waves. I will not repeat that. If I ask you any properties, that please write one property, or I will give you some a question and give you 4 options. One of the option is electromagnetic waves. So you have to say that radiation energy is similar property with the electromagnetic waves. So you have to know all the properties of electromagnetic waves. That is, it will exhibit various phenomena like interference, diffraction, polarization, all of these things, and it travels with velocity, that is velocity of light. Here you have to remember one more thing. I already told you that wavelength of the thermal radiation, so that is radiation, you will see the difference in between the electromagnetic waves. That is the simple difference. Now, after that, we have discussed some relation A plus R plus T equal to 1. What is A and what is R and what is T here?
Sir,
A
absorbance.
for absorbed energy,
Absorbing power,
reflection energy,
radiation
transmitted
power.
energy.
Okay, so this is absorptance, this is reflectance, and this is transmittance. So basically, I have this relation, because before that we have this relation only, where we have already showed this is sun, q1 amount of it is coming and q1 amount of it is absorbed, q2 is reflected and q2 is transmitted. So from this you will see this energy ratio, absorbed part to the incident part is called absorptance, this is reflectance, and this is transmittance. Now here is the main important point that you have already heard this term also, A lambda, right? If it is A, that is absorptance, so what do you mean by A lambda?
The
Absorption
spectral
power.
absorption power.
Okay, so spectral absorbing power is the name, obviously, right? But if I ask you, what is the difference between A and A lambda?
At constant
Obviously.
wavelength.
Exactly. So here I am mentioning you, please find out the A. A means the absorptance coefficient at any particular wavelength. So here wavelength is mentioned because if you see that Q means something thermal energy, right? The incident energy. So energy you can write it down hc by lambda. So some amount of this energy is incident some body. Okay, so that means you have to mention first that what amount of energy is incident on that body. So if you are changing the lambda, the amount of energy will be changed. So that's why you have to mention. So A is the for definition is right. So what is the definition of absorptance? But most of the case you have to use A lambda because maybe you are using A, but you have already fixed that value of lambda for any particular energy. Okay. So similarly, you will see some E. What is E here? Small e, not the charge of electron. What is E here?
Emissive
For
Sir,
the
radiation.
emissive.
Black body radiation.
Emissive power.
No. Emissive power. Someone said emissive power. That is the emissive power. Emissive power means that any body at any particular temperature emits energy per unit area per unit. Energy per unit area per unit time is called the emissive power. I will come later the concept of black body after that. So if I ask you any emissive power, that is simply relation energy per unit area per unit time. Clear? So this is energy. Now A plus R plus T equal to 1. This is the radiation equation for any normal body, right? Why I'm saying normal body? Let's say this is some body and some amount of heat Q is incident on that body, and Q1 is the amount of it absorbed, Q2 reflected, and Q3 transmitted. Then your relation become like this: A plus R plus T equal to 1. Now, what is the black body then?
A is equal to 1.
A is equal to 1.
A equal to 1.
R and T is equal to 0.
So R and T equal to 0. So if I ask you, what is the physical representation of that equation?
All light is absorbed. All heat is absorbed.
So basically, it's something, it's a body where all the energy will be absorbed. That means there will be no reflected part and no transmitted part. Similarly, if I ask you for white body, that will be A equal to 0, R equal to, and T equal to.
equal
Which
to
one will be
one.
1? R equal to
R
1.
R
equal
equal to 1.
R equals to 1.
Exactly. Please remember this. Maybe this is not is actually in my class note. But remember this. So up to this, we have two types of material. One is normal material, where this equation is A plus R plus T equal to 1, and another equation is A equal to 1. But I told you before, A equal to 1, which is theoretically correct. Obviously, if I write Q1 equal to Q, so your total absorbed part is equals to the incident part. So you can write it down. This is equal to 1. So this is right. But in actual practice, you will not find any body which is perfectly black body. Clear? Just remember this, that perfectly black body is impossible. But for mathematical, for numericals, for definition, you have to write it down. The what is the meaning of this perfectly black body where A equal to 1. Just remember this. And if I ask you one question, that I will draw some image. Let's say E lambda by A lambda equal to capital E lambda. Just tell me, what does it mean E lambda, and what does it A lambda, and what does it capital E lambda?
So E lambda is emissive power at lambda. A is
Okay.
absorptive power at lambda, and E is the energy of a photon having a wavelength lambda.
Okay, so is there anyone who can answer the question? No one?
Sir, E lambda is a constant.
Someone said constant, someone said energy. So is there anyone?
E lambda is spectral emissive power, small e lambda.
Obviously, spectral emissive power or emissive power at any particular wavelength, both are same, right? So spectral emissive power in
Immediate
one
power
light.
of a perfect black body.
Who said that?
Devanjan, sir.
Devanjan. Okay, so actually he is right. This relation is called the Kirchhoff's law. Kirchhoff's law is basically that if I say normal body and black body, Kirchhoff's law gives makes some bridge in between the normal body and black body. If you see these two parameters, I told you before that if I see any small word or small letter, that will be related to normal body radiation. But if I write capital E, that's why in the previous in the emissivity term, I changed that E into energy per time per area, because if I write E, so here I am using that capital E, that is also the emissive power. This is also emissive power, and this is also emissive power, but you have to make sure the difference between the normal body and the black body. So that's why we have written this E lambda is the emissive power of normal body, but the capital E lambda is the emissive power of the black body. Clear?
Yes, sir.
And just remember this, why I am saying that you have changed that notation capital E lambda, because you can see for normal body there are 3 parameters, but for black body there is only 1 parameter, right? That means all the energy is absorbed. That means the parameter value will be different. So that's how we have taken that E lambda is the emissive power of any black body. Okay, fine. Now if I ask you one example of black body, not exactly perfectly black body, if I ask you that one example of a black, which one will give?
Carbonate.
Anyone?
Sir, a completely reflecting sphere with a small hole.
Small hole.
So
So if I ask you that from my class note, I have already given at least 3 examples.
The lamp black or platinum black.
Lamp black, platinum black, various black body. There are various black body. You can tell anything. Okay, so that is the black body. And just remember, for numerical and theoretical purpose, the perfect black body is there, but for practical point of view, you will not find any body which is perfectly black body. That means all the 100% of the energy will be absorbed by the body. It is impossible. Okay. Now E equal to sigma t to the power 4 minus t0 to the power 4. I ask you, I have written some relation here. This E is actually energy. Okay, this E is the energy, but I am asking you that what do you mean by this relation? If I write this equation, but what does it mean by this relation?
So energy per area.
So someone said energy per area. Okay, then please explain this one by one.
Energy per unit second per unit area.
Per unit area. Okay, then
Per unit second.
okay, fine. So what is T and what is T0? My point is that how, please explain all of these things term. So how will we explain this equation? If I ask you y equal to mx plus c, you can say m is the slope, c is the intercept, y is the this, right? So if I
Yes,
ask
sir.
you not exactly like this, if I ask you, it is something based on some theory, right? Some definition. So I want you to make some definition. What does it mean here?
So T is the
The total
temperature
amount
of
heat
T
the
of
is the
body,
temperature of the body, and T naught is the
and T naught
temperature
is
of
the
the
temperature of the
surrounding.
surroundings,
Exactly.
and
That
sigma
is
is
the
this
point.
distance constant.
Exactly. So most of the case you will see there will be no T0. Why? Most
So
of the
because we
case you
assume
will
that there
Because
is
the
no surroundings.
exactly.
isolated.
Exactly. Please remember this. If the surrounding temperature is there, then only you can change the relation T0 to T to the power 4 minus T0 to the power 4. Because for any black body, if I take this black body at which is maintained on capital T temperature, it radiates the energy. And this is called also Stefan Boltzmann law, right?
Yes, sir.
And
Yes.
and just remember that Stefan made this experimental point of view, but Boltzmann gave you the theoretical point of view. That's why we make that formula Stefan Boltzmann. Don't have to remember this, which will give the theoretical and practical. Just remember this is also called the Stefan Boltzmann law. Okay. Now my point is that this E is not actually the E. What is that? Energy per unit area per unit time. Please remember this, because it will change the whole unit, right? Because if I write this is joule, this is second, and this is area, but if I write only E, that means the unit will be changed, right? So that's why for numerical purpose, please remember this whenever using any equation. Please remember this which equation you have used. Otherwise you just add T into A in the right hand side. Okay, so please remember this, the relation. If it is online, then it's okay, I will give you the unit also, right? But if it is offline, I don't know. Please, that's why you have to remember this. Okay, so that is the Stefan Boltzmann relation. Now coming to the relation that lambda am into T equal to B, what does it mean and why we need this, and what is the importance of this relation, and what is the name of this equation? Are you checking my class note?
Law.
Lambda m proportional to 1 by T.
Why?
Wind displacement law.
So someone said lambda by T, that is Debanjan, right?
Yes, sir.
So can you just explain this, why the lambda m is equal to 1 by T? See, from this relation you will get some problem, some equation, sorry, some theoretical type question in the essay. I will ask that question, the wavelength varies with temperature in which way, right? In proportional, inversely proportional. So I will formulate that type of question.
যদি ব্ল্যাক বডি টেম্পারেচার যদি বাড়ানো হয় তাহলে কার্ভটা ছোট হতে থাকে।
কেন ছোট হতে থাকে? Why? That is the question. This is the black body. You are increasing the temperature, right? And you said that the wavelength of the energy continuously decreasing. So in your statement, answer is there already.
Inversely proportional.
Sir,
Okay, carry on.
so the lambda max has to decrease, and because temperature is increasing, so the power that is emitted per unit area has also need to increase. So that
Yes,
in that case,
exactly.
the area under the curve needs to increase, so the curve becomes
Exactly.
flat.
Simply. The Debanjan already started, but he failed to explain. Because if you increase the temperature, if you can see E by time into area equal to sigma T to the power 4. Forgot about T0. That means something, this relation, the energy is something relation energy versus T, right? Like this, forgot about T to the power 4. That is, if you're increasing the temperature, the energy will be increased. So if you
Yes, sir.
increase the temperature of the black body, what happened? The energy will be increased.
Increase.
Okay, now just see that representation of the energy. So if I write like this, it's clear. This is temperature and energy. Energy is hc by
Yes, sir.
lambda. So hc by lambda 1 by lambda. It's clear.
Yes, sir.
So simply, if you want to increase the energy, you have to make sure that your wavelength is continuously decreasing. So it's obvious, if you increase the temperature, your wavelength continuously decreasing. That means the energy is increasing. So that's why the relation become lambda T equal to B, that is Wien's displacement law. And what is the importance of this relation? Why we need this? What is the main reason of this? Main reason, not exactly the main reason, but importance of the Wien's displacement law.
It is
So
used
to
to
find
calculate
the
the
It is
maximum.
needed
temperature
to
of
find the
celestial
temperature of
bodies.
heavenly bodies.
Exactly. So just remember lambda T and B. B you have to remember this. This is Stefan constant. Sorry, Wien's constant. That is 2.88 in 10 to the power minus third millikelvin. You have to remember this. Maybe in the exam this value will not be there. Sigma value and B value, capital R is the universal gas constant. This value you have to remember this. I will not give you that parameter value in the question. Okay. Now lambda T. So here is only two unknown parameter, lambda and the T. So once you know the one parameter, you will get another parameter, right? So most of the case you will know the value of wavelength because the radiation is already done. So that's why you just find it the temperature. Okay. Now coming to the first law and second law of thermodynamics. If I ask you one question, what do you mean by thermal radiation? So for heat radiation, is there any question, any doubts?
No, sir.
I will discuss again before the essay also. I think you have already offline class, right? From this
Yes,
week.
sir. Yes, sir.
Yes, sir. Offline class শুরু হচ্ছে বুধবার দিন থেকে শুরু হচ্ছে
If this is F5, oh okay. I don't have any offline class for F5. Okay. So what do you mean by thermal equilibrium? If I ask you one question, what do you mean by thermal equilibrium?
When there is no transfer of heat from one body to another.
So someone said when there will be two temperature will be the same. Both are right. That means two differently temperature bodies are in contact, and you will see the heat will transfer, and after some time later the temperature will same. Temperature will be the same, which is the obviously is called the thermal equilibrium. But the reason is that you have to say that the energy of these two bodies are same because they are exchanging their energy, not the heat.
internal energy.
Internal energy. You can say the heat, but which is not exactly right. No one will oppose you that you are actually transferring the temperature, but you have to say the heat or energy. You can say that is the appropriate term, right? That is the thermal equilibrium. Now, what is zeroth law of thermodynamics? What is zeroth law?
Sir, if A and B are in equilibrium, thermal equilibrium, and B and C are in thermal equilibrium, then A and C will be in thermal equilibrium.
এ আর বি এর মধ্যে ওয়ালটা হবে ডায়াথার্মিক।
Okay, so both are right, but if you ask you to explain this, then you have to use the wall concept. Okay, but for definition purpose, both are right. That I gave you the example that for thermal equilibrium, you have to make sure that the wall where there will be some transfer of heat, otherwise it will not reach any thermal equilibrium condition, right? So that's why the wall is very, very important term. So I told you there are two types of wall. One is called diathermic and another is adiabatic, right?
অ্যাডিয়াবেটিক, ইয়েস স্যার।
Diathermic means it will allows to exchange the energy, but in the case of diathermic, it does not. So if I take the body A and body B, and let's say in between these two body, the wall is diathermic wall. That means let's say this is TA temperature and this is TB temperature. That means they will not reach in thermal equilibrium condition because the wall in between these two bodies are diathermic wall. Now if I make another wall, and here you will see the another body. Here this A and C are made by some conducting wall or diathermic wall, and this wall is conducting wall. And let's say this is TC temperature. So after some time later, you will see TA will be TC because they will exchange the energy, and B and C will exchange the energy. TB will be TC. So basically, that is the main concept. Okay.
ওকে স্যার।
And there are various type of thermodynamical process: isothermal, adiabatic, isochoric, isobaric, cyclic, non-cyclic, quasi-static, isolated system. But in this MTA, I gave some question relating to isothermal process, right? That in which process the heat will transfer in between the system and the surroundings. Right? Can you just remember that I gave you some problem relating the first law of, isothermal process, that in which process that heat will transfer, adiabatic, isothermal, I think cyclic, and one more the relation, right? Can you just remember this? No. So am I audible now? I think some call has come.
Yes, sir, you are audible.
Okay. I think there is some relation, there is some problem I have already gave in the examination. So you just remember for what is isothermal. Isothermal means there are only three parameters. If you make constant temperature, that is called isothermal. If you make constant volume, that is isovolumic or isochoric. If you make constant pressure, that is called isobaric. But if all the three terms are changing, that is called adiabatic. Now in the case of isothermal and adiabatic, you will see, just remember, isothermal means the wall obviously of the system will be diathermic, but if I say it is adiabatic, the wall will be adiabatic, that is non-conducting wall. So that's why for isothermal process, the system will exchange energy in between the system and with the surroundings, but in the case of adiabatic process, you will not see that type of process. Okay. Now I think within 1 minute the class will be end. Please join again. I will take only 5 more minutes. Okay.
ওকে স্যার।
Okay, so what do you mean by this relation? dq equal to du plus dw.
It is
The
a
first
first
law.
law. First law.
So first law, obviously first law, but if I ask you, please give the definition. Definition, not exactly just to give the book is definition. You have to say in your own language. You can say. So what does it mean? dq equal to du plus dw.
Sir, if any heat is given to a body, then its internal energy increases and it does some work.
Body or any system.
Any
So
system.
So if I give you that heat, you will do some amount of mechanical work done? No. So you have to say the system, right?
Yes, sir.
Work.
Okay. So this is the one relation, and another relation is W equal to JQ. What does it mean?
Joule's law.
Joule law.
What does it mean? Obviously, the law name is actually the Joule's law.
Sir, work and heat are related.
Relation between what
There
and
is work done. There obviously there will be some amount of heat will be produced. Okay, and you will see the work done and heat in amount both are same in amount. Just remember this. Okay, that's why you can say the I can say the work done equivalence of heat something law like this. You can say. Okay, and the J is the Joule's constant. And this Joule's value, J value, I will give you. Why? Because most of the case you will see 1.4.186, or you can say this is 14.2. So if you change that 1.186 to 2, there will be some digit change in digit, right? So that's why for this purpose I will give you that value. Okay.
Okay, sir.
Now coming to there are two work done equation I have discussed in isothermal process. Some work done equation. This is the general equation, that is dW equal to PdV, because if I write work done equal to pressure into volume. Now if I convert into the isothermal process, so that is W equal to RT log E V2 by V1, right? If I increase the volume, in terms of volume it will be like this, but in terms of pressure that will be P1 by P2.
1 by
Clear?
P2. Yes, sir.
Just remember this. So here, is there anyone that why we have written V2 by V1, but in the case of pressure we have written P1 by P2? Is there anyone? Any problem?
no, sir.
No, sir. No, sir.
So just remember this concept that PV equal to RT. Let's say there are two PV equal to RT. Let's say gas started with state number 1 to state number 2. So gas, if some thermodynamical process is happening, let's say gas started from P1 V1, and we have maintained the isothermal concept. So that's why the temperature is T constant. Now after some time later, you will see the gas reaches some pressure P2 and volume V2. You will see throughout the system the temperature will be constant. That's why RT is constant. So RT is constant means, see, P1 V1 equal to P2 V2. So from this relation, V2 by V1 equal to P1 by P2. Clear? So first calculate the work done equation in terms of volume, then just replace this. And adiabatic equation, you will see the relation W equal to R by gamma minus 1, T1 minus T2 equal to this, right? If I change the temperature from T1 to T2 temperature here, and I
Yes,
will
sir.
take one class to find out the various value of gamma. I will take the class. Please just remember that the various value of gamma, and I told you that most of the case you have to remember this. Okay. Now coming to the second law of thermodynamics.
Sir, your voice was muted for some time.
Exactly. Actually, I will take that gamma value class, that gamma value for monoatomic, gamma value for diatomic and triatomic molecule. I will take the class how to calculate if you are forgotten inside the examination hall, how to remember that gamma value. I will teach you the procedure how to calculate the gamma value. Okay. Maybe it
Okay,
will
sir.
take some time, but you will get that right answer. And I said that most of the case we will take the gamma value is 1.4 because 1.4 is the gamma value of diatomic molecule and diatomic molecule. And in our environment, you will see that most of the molecules, small gas molecules, are diatomic. Okay.
Yes, sir.
So you can see that in a physics, most of the case we are taken as we are using the assuming term, right? Not exactly all the gas molecules are the diatomic molecule, right? So why are you using gamma value equal to 1.4? You have to say in mathematics also you will see if we start with some integration problem x plus 1 plus x square into dx, we have started with let x equal to tan theta. Why we are using this concept x equal to tan theta? Who said this?
Because 1 plus tan square is equal to
Okay,
6.
okay. I know this because if you are using this, then only you can calculate this problem. But my question is why x equal tan theta all the time? Just think about it. Why?
So to apply the laws of trigonometry.
Obviously. But I will tell you the story any other class that why all the time, because in most of the case you will see if you are going to that why not another term, it will take more time. The scientists are made several experiment, then we have got some relation. Because I am telling you something that you are not discovering anything. Your teacher already told that just use x equal tan theta, right? But I am telling you that for all that time the gamma value is 1.4. We are assuming. If you ask me that questions why, I don't have any answer, because I have read some books and some scientists have said that we have to take this consideration, then only you can solve this problem. If I disagree with them, I have to calculate all this theory, right? So that's why. So in physics, most of the case you will see we are assuming. Okay, forgot about all these things. Okay, so we have the two law in second law of thermodynamics, right? And one is Kelvin Planck and another is Rudolf Clausius, right? So Kelvin Planck is basically based on the heat engine, and heat engine has the efficiency. What is the efficiency? 1 minus Q2 by Q1. But if I modify it with the Carnot ideal heat engine, that will be 1 minus T2 by T1. Clear? So for normal heat engine, it will be the Q2 by Q1, but for Carnot ideal heat engine, it will be the T2 by T1. And just remember the main formula, main important is that what is the working substance of Carnot ideal heat engine? That is the ideal gas. And for refrigerator, that relation is called beta, is the coefficient of performance T2 by T1 by T2. And for all this case, for any heat engine, Carnot heat engine, and refrigerator, all these three cases we have taken T1, which is maintained higher temperature, T2 is lower temperature. Clear? But you have to remember for heat engine or any Carnot heat engine, higher temperature region means the source, a lower temperature region means the sink.
Sink.
But in refrigerator, we are not using any term the sink and the source. We are using the high temperature region, the low temperature region. Clear? Clear, everyone?
Yes, sir.
Yes, sir.
Okay. So if you need anything, anyone, I will take another revision class. because obviously after statistical mechanics, for this for today it's finished right now. Okay, so Sir, please take the screenshot and send to me.
Thank you, sir.
Thank you. So is there
Thank you, sir.
anyone have any problem for today's class?
No, sir.
No, sir.
No, sir.
No, sir.
Okay, thank you.
স্যার
Thank
এটা
you,
তাহলে
sir.
বলে দেন x ইকুয়াল টু tan থিটা কেন ধরি?
না 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 আমি জানি না তো, আমি কি বললাম, আমি বললাম আমি পরে বলবো যে তোমরা সবসময় এরকম করে, আমরা ম্যাথমেটিক্স শুরু করেছি, এই কোশ্চেনটা আমারও পরে এসেছে অবশ্যই আফটার এইচএস, that why you are taking that x equal to tan theta, why you are taking some trigonometry problem x equal to cos theta, why x equal to sin theta, why? Just for your own invention, just recapitulate it. Okay, I will check that why it is all the time x equal tan theta. Okay, thank you everyone.
Okay, sir. Thank you.
Okay, sir.